Trapezoids and kites. This is going to be the final section that we're bringing up any new quadrilaterals. So we're going to talk about trapezoids, isosceles trapezoids, and kite. We have two theorems for an isosceles trapezoid. First, we have to talk about what a trapezoid is. So if I have a trapezoid, that means that I have a pair of opposite sides are parallel, and then the two other sides are not. So this would be considered a trapezoid because my top and bottom would be parallel. The two lines that are parallel sides, are called your bases. Parallel sides, bases. And the sides that are not parallel are called your legs. So when I'm talking about an isosceles trapezoid, this is typically how you see trapezoids drawn, and that's because I still have my bases that are parallel, but my legs will always be congruent in an isosceles trapezoid. So when I have 619, it's saying if a quadrilateral is an isosceles trapezoid, so a picture like this, then the base angles are congruent. So this angle right here would be congruent to this angle right here, and this larger angle would be congruent to this larger angle. So the two angles that lie on a base side are congruent when you have an isosceles trapezoid. And then I have 6-20. If I have an isosceles trapezoid, then I know the diagonals are congruent. So that diagonals are when you draw the line from two opposite angles. So in this case, A, B, C, D. And in this picture, AC would be congruent to BD because those are my diagonals. And those are two things that are true for an isosceles trapezoid. So I have this problem now. It's saying that RSTU is an isosceles trapezoid. So right now I could draw in, since this is isosceles, that that RS is going to be parallel to UT because it's saying it's a trapezoid. And since it is isosceles, I could say RU is congruent to ST. It's asking me for all my different side lengths, or my different angles. So my base angles are going to be congruent. So here is one parallel side. So that means the other angle created by the other leg is also going to be 75 degrees. So angle R is going to be equal to 75 degrees. When I look at this picture, all the angles equal 360, or else you could also say whenever you have two angles that are on the same leg, so here's the same leg, those angles add up to 180. So 75 plus angle U is going to equal 180. If I solve for angle U, that's going to be equal to 105 degrees. And since I know angle U is 105 degrees, and U and T are on the same base, then angle T is going to be equal to 105 degrees. So angles on the same leg are supplementary, and angles on the same base are congruent. So it's saying what are the values of x and y in the isosceles triangle below? It's saying D, E, and B, C are parallel. Well, first it's telling me this is an isosceles triangle. So if this is an isosceles triangle, that means AC is congruent to AB, meaning my two base angles are going to be congruent. So I'm going to write Y over here. So I can figure out what angle Y is. So if I just draw the isosceles triangle here, my opposite angles of my congruent sides are congruent. So Y and Y and 32. So now I can set up an equation 2y plus 32 is equal to 180. So I got Y is equal to 74 degrees. So in this picture also, it's telling me that DE is parallel to BC. So if I really to draw this out, this right here is a trapezoid. And since both X and Y lie on the same leg, these two would be an isosceles trapezoid because this is an isosceles triangle. So then I know that X plus Y, which is 74, is going to be equal to 180. So if I subtract 74 from both sides, I get X is equal to 106. So those would be my two answers for this problem. So I have another theorem here on trapezoid mid-segment. So if I have a trapezoid, then the mid-segment, so mid-segment is the line that's drawn in the middle of the trapezoid. And when you draw this mid-segment, it creates two congruent parts on your legs. And this is for any trapezoid, not just for an isosceles, so that's why I drew the tick marks as different. But the key here is the length of the midsegment. So if I put X at my midsegment, and I have A and B, let's say that those are lengths, then the midsegment will be half the sum of my two bases. So X will be equal to A plus B divided by 2. So let me try to put some actual numbers in there that will help you. Let's say if this was 6, down here was 10, then X would be equal to 6 plus 10 divided by 2, which is equal to 16 divided by 2, so X would be equal to 8. So it's adding your two bases up and dividing by 2 to find your midsegment. So I'm going to do this problem. It's telling me that TU is the midsegment, so I can write up an equation. Because my midsegment, which is 2x plus 10, is equal to my base plus my other base, that whole thing divided by 2. So there's a couple of different ways that you can solve this, because with algebra there's always more than one. What I'm going to do is, since this whole thing is being divided by 2, I'm going to multiply by 2 on one side, and then multiply 2 on the other side. So I'm distributing my 2 on the left-hand side, and I get 4x plus 20. It's going to be equal to 6x plus 16, because I combined these like terms to get my 16. And now I'm going to solve for x. So I subtract 4x, I have 2x, I'm going to subtract 16, and I would get 4 divided by 2, I get x is equal to 2. That would be my final answer. Again, you just have to set up the equation. And then my last shape is a kite. When I have a kite, basically what I have is two side lengths that are congruent when they're right next to each other. Here and here, here and here. With every kite, there is two isosceles triangles within that kite. So if I were to draw this line right here, this blue triangle would be an isosceles triangle, and this red triangle would be an isosceles triangle, because two side lengths that are next to each other on the kite form isosceles triangle when you cut them in half. So the theorem that I have about a kite is, if a quadrilateral is a kite, so right here, the only thing you have to know is that two sides that are right next to each other are congruent, that makes a kite. Then the diagonals are perpendicular. Remember, perpendicular create that special kind of angle, and that's going to be a 90-degree angle. So I want to fill in everything I know here. It's saying that ABCD is a kite. Right away, I can say that angle 1 is going to be equal to 90 degrees, because those perpendicular parts bisect each other. I also see that I have this isosceles triangle right here, because these two sides would be congruent. So if this side is 40, this angle right here is 40. So I'm going to enlarge just this triangle, the blue triangle. So I found out that this is 40 because I used the isosceles triangle. I know that the diagonals bisect each other, so that's going to be 90. And I have to figure out what this angle is. So I can do 40 plus 90 plus angle 2 is equal to 180. And I would get that angle 2 is equal to 50. Because I combine like terms here, I get 130, and subtract 130 from 180 would be 50 degrees. So these would be my two angle measurements for angle 1 and 2. Make sure you fill out the Google form and have a great evening. I'll see ya.